For this technology assignment, we are asked to find out how long it will take Jack and Diane to have deposited $10,000 into their account. So in the beginning of the account, $2,000 is deposited, and then they're going to deposit $175 a month. So the first thing we're going to do is we're going to fill out this column here with the number of months, and I'm going to add in a 1. And then I'm going to highlight 0 and 1, and then I'm going to pull this down, and we're going to go down to about 50 months. All right, there we go. Now we're going to enter in a formula in cell C3. So I'm going to hit equals for my formula, and what we want to do is we want to use cell references. So here we have our constant, $2,000, and we're going to click on that cell. And this, I don't want this to change. Okay, so I'm going to click on that cell, and then I'm going to go right before it. So what I'm going to do is I'm going to enter in the little $sign. And that's going to say that this cell is not going to change. This is a permanent cell. Don't change even if we pull down the formula. Okay, so that's kind of set in stone. And we're going to say, so that's our initial amount. So I'm going to hit enter for a second. So let's kind of work through our plan of what we're doing. What we're doing is we're saying the initial amount, so the initial deposit, so this is how much we're starting out with at the beginning, and we're going to add to that, the number of months that we're actually depositing. So for the first month, we would say, well, that's 1 month times $175. Okay, so that would be 1 month of deposits. What we want to be able to do is we want to be able to evaluate it at 2 months, 3 months, 6 months, and even all the way up to 50 months. So I don't want to actually enter in those exact values, but I want to use cell references. So the C2 is our initial amount. We're putting $signs in front of the column and in front of the row to say don't change that cell. Plus, we're going to say the number of months. So this is B3, and that's going to change. That's our variable. So B3 is our variable. That's what's going to change. The number of months is going to change as we go down. Times the monthly deposit. And we're going to click on that cell as well. Now we don't want that cell to change, so I'm going to go in front of A, and I'm going to put a little $sign to say keep that still. If I can do this. There we go. And then in front of the 2, I'm also going to hit a $sign. What we want to be able to do is copy this down, and once again, we don't want this cell to change, and we don't want this cell to change. We want this cell to change the number of months. So B3 is going to change as we pull it down. Alright, so I'm going to hit enter. So after the first month, it makes sense we would have $2,175. Alright, so let's pull this down, pull this formula down. So I'm going to highlight that cell, then I'm going to pull down with the little plus sign all the way to 50. Let's make sure that it makes sense and we did this correctly. Okay. So it makes sense here that for the second month we would have 2,000, and then we have 2 monthly deposits, so 175 times 2 would be 350. So that makes sense. What we're asked to do is to figure out how many months does it take for Jack and Diane to have $10,000. And that's our question. Alright, so how many months? And I want you to put this into your answer as well. So I'm going to go down, we're going to look down, and we're going to say, okay, so they have, right about here at 45 months, they do not have $10,000 yet, so I'm not going to say 45. At 46 months, they have more than $10,000, but we want to at least make sure they have $10,000. That's their goal. So it takes 46 months for them to have acquired $10,000. All right. So the point of the lesson is to see B3 as kind of that variable. So notice that when I look into the next cell, this is referencing B4. And if you click in the little formula box, let's do that. We can see all the cells that are being used here. It's the initial amount, that stays the same, plus B4, so 2 times A2, so that monthly deposit. So it's kind of nice, if you're not sure what's happening with the formula, if you click on that cell, click in the little formula box, and it'll highlight the cells that are being used. So this is saying 2,000 for the blue, for C2, plus the number of months of deposits. So now we're talking about B12, so it's 10 months of deposits times the amount for each monthly deposit. Okay, so we can hit enter. Now, the reason why we want to do it like this is because we want to know, well, what if we change something? So if I change this to be $300, let's say a month, I want to see how that's going to change all of those values. And let's say that they decide, hey, we can deposit a little more. I can deposit $5,000 initially. Then how long will it take them to actually earn $10,000? Well, in this circumstance, it'll take them only 17 months to acquire the $10,000. It could be that they don't have $2,000 to deposit. Let's say they have $1,000 to deposit. And let's say they up their monthly deposit. So they say, well, we can deposit $350 a month. So that maybe their initial deposit is a little smaller, their monthly deposit is a little larger. In this case, if they deposited more per month, they could have $10,000 in 26 months. Okay, so we want to be able to set up those formulas dynamically so we can change the conditions very quickly and still come up with a solution.